Let's do some compound interest. So let's suppose Dan Druff invests $1,000 in Head & Shoulders stock. Let's say the company promises to pay him 8% simple interest. How much money total will Dan have after 1 year? I want you to think about how to solve this problem. Stop the video. Okay, now that you've done that, let's solve the problem together. If this is simple interest, we know I equals PRT. And so now this is interesting. Total money, or money total. We could do this. We could do I equals PRT. And let's see, principal is $1,000. The interest rate is 0.08 per 1 year. 8% per 1 year. Times, let's see, 1 year is 1,000 times 0.08 is, I believe, $80. 80 bucks. So now amount equals 1,000 plus 80 equals 1,080. But wait, there's more. Here's another way to think about it. Do you remember that 80 was A equals 1,000 plus 80 came from multiplying 1,000 by 0.08. And notice that both of these terms have a factor of 1,000. Terms are separated by addition. So we can write this expression that has two terms. We can write this factor of 1,000 twice, or we can write it once, leaving us with 1 plus 0.08. Notice that this is 1 times 1,000, and this is 0.08 times 1,000. So really, this is the same as 1,000 times 1.08 when you add. So here's the point I want to make. A is P plus PRT, or P1 plus RT. I don't care how you do it. I just want you to know that all of these are valid ways to do this because knowledge is power. Okay. What if the company pays him 8% interest compounded quarterly? So this is a little different, right? So let's look at this and see what happens. So what quarterly means is that they would give you a quarter of 8% 4 times a year. So let's go amount 1 equals P1 plus RT. I'm going to use this factored version because it's a little cleaner. So we get 1,000. 1 plus, now it's 0.08 per 1 year times 4, sorry, wrong thing, times 1/4 of 1 year, because remember we're only going to get this interest rate, interest rate. We're doing this for the first quarter, so we're not going to get 8%. We're going to get a quarter of 8%. So yeah. So we get 1,000 times 1 plus 0.08 over 4, better known as 1,000 times 1.02, which is 1,020. So I know what you're thinking, but that's not as good as what we got last time. We got 1,080, but remember, this is only 1/4. So so the amount in quarter 2 is the amount in quarter 1 plus P1 plus RT. Remember, that was 1,020 plus, or rather, sorry, this is not plus. This is A1, jeez, Roger. A1 times 1 plus 0.08 divided by 4. Because that's why it's called compounded interest, because you take the interest you earned in the last compounding cycle, and then you get interest on top of that interest. And then A1, remember, is 1,020 times 1 plus 0.02. And let's see, what does that come out to be? Well, I don't know. I'm going to show you a cool trick. 1.02 So we're good there. And now we can get our calculators out and multiply this. What I really want you to notice is, where did 1,020 came from? Right over here. 1,000 times 1.02, that's 1,020, times 1.02. So it's 1,000 1.02 quantity squared. So what's going to happen in the long run, and I ran out of room here, so let me just pull up a sketchbook here. Skip. Always skip. I don't care. So amount is the 1,000 1 plus 0.08 divided by 4 to the fourth. Oh, wait, sorry. I'm getting ahead of myself. A3 should be 1,000 1.02 to the 3. And finally, A4 is 1,000 1.02 to the 4. So compound interest comes from simple interest. So they're not different. It's just that simple interest, you only get interest on the original principal, whereas with compound interest, the interest you earn gets interest as well. So the way we're going to do this is say that the amount is the principal times 1 plus the annual interest rate divided by the number of compounds per year to the m times t. And so now let's go solve a problem with that. Well, I guess we already did. You can do this computation, and we should get, I don't know, I should have done this before, but I didn't. I'm a terrible person. Please forgive me. So we get 1.02 to the fourth. It's that number, and I'm just going to leave that on my screen. Now I'm going to multiply by 1,000, which I could have done by moving decimal points, but I didn't. 1082 $1,082.43. So we actually beat simple interest by $2.43. Whoop-de-doo. Okay. Now, maybe you're wondering, what if we compounded monthly? Let's try that. And I'm going to go back over here. So A is 1,000. That's the principal. 1 plus, we're still getting annual interest of 8%, but if we compound monthly, we're going to divide by 12. We're going to get 12 compounds instead of 4. And then we're going to do 12, and remember this is 12 months per 1 year times 1 year. So this is 12 times 1, better known as 12. 1,000, 1 plus, okay, clear, 0.08 divided by 12 is that. And I'm going to leave these numbers in my calculator, and then I'm going to go, here's to the power of 12, then I multiply by 1,000, and it doesn't seem like we got a lot more. And so I'm going to scribble this out because I didn't write down the intermediate steps. 1,082.99. Now stop for a minute and think. Is this bothering you? Were you expecting more? I mean, that's like not even $1 more. So that might be bothering you. So let's talk about that a little bit more. So, what if he compounds daily? A equals P1 plus R over M to the MT. So, A equals 1,000, 1 plus 0.08, 365 days in a year. And be careful, on some of the homework problems, you're told to assume a 360-day year, which I think bankers do sometimes. So it's, again, 365 days per 1 year times 1 year is 365 compounds. And so make a prediction. Is this number going to be a lot bigger than the one that we got last time? About the same? just think about what you expect. 0.08 divided by 365 plus 1 to the power of 365 times 1,000. We got up to an extra, we got past $82, to 1,082, so 28 cents. Doesn't seem like compounding more often gives us much of a return, like much of an increased return. We're still doing better than simple interest, but perhaps not as much as you expected. So I made this little spreadsheet. Let's suppose some chump gives you 100% interest. That would be 1 in the percent in the compound interest formula. So n is the number of compounds, and n again is the number of compounds. So if n equals 1, you're getting compounding annually, and your dollar, if you invest $1, we're just saying P equals principal equals 1. If you invest $1 and you compound annually at 100% interest, after a year you have $2. Not bad. So again, let me review. This is assuming that the principal is $1. We're given 100% interest compounded continuously, or 100% interest, and we're going to look at what happens as we increase the number of compounds. So if we compound annually 100% interest, $1 turns into $2. What do you think will happen if we compound twice as often? Well, we get an extra quarter if we compound semi-annually. What do you think will happen quarterly? It's like an extra 19 cents monthly. Is that what, 17 cents extra compared to the last step? About 10 cents more? Oh no! Come on, every hour? That's got to do more than that. We're this. I mean, I guess maybe to the nearest cent we got another. I'm not sure. I am skeptical of this computation. That doesn't look right to me. I wonder if I'm running up against machine error. That looks right. I think 1 over A9. I don't know. I'm going to delete this one because I don't think that's right. But all these others are definitely right, because what happens here is something really pretty interesting. So as the number of compounds increases, 1 plus 1 over n to the n approaches this pretty cool number, E, not a letter, a number, and it's approximately equal to 2.7 Andrew Jackson. Andrew Jackson, my friend Ben taught me this. Andrew Jackson was elected president in 1828. So E is a very special type of number, and it turns out that that's what happens as you let the number of compounds increase as big as you want. You come up against this boundary number E. So that's the best you can do with continuous compounding, is what we call it. So we did this daily. And so this is what happens as the number of compounds increases. The compound interest formula. I'm going to skip this problem because we already did one like this. I'm going to let you work through this one and send me an email if you have questions. I want to look at a continuous compounding because that's what we were just talking about. So the continuous compound interest formula, let's compare compound interest. A equals P1 plus R over M to the MT. Continuous compounding is given by A equals principal again, but instead of 1 plus RM to the MT, remember that as 1 plus R over M to the MT is the number of compounds increases, this whole expression approaches this funky number E. So that's the formula we use for continuous compounding. So here we get A equals 5,000 times E to the 0.0693 times 4. Now notice that when you're using continuous compounding, we're not taking the annual interest and dividing by the number of compounds, because with continuous compounding, we've done away with this expression approaches E as the number of compounds increase. So we don't have to do that with continuous compounding. All we need is this number E. So here's how you work this out. We're going to take 0.0693 times 4, enter, then E to the, and now that's E to the 0.0693 times 4 times 5,000. And that's 65997.15. That's in dollars. So that's how much interest you'd get on $5,000 invested at that interest rate for 4 years, compounded continuous. So you make almost $1,600. Not bad. Let's do one more. You try it. Oh, wait, sorry, just kidding. This is a different type of problem, and I'm going to make this as a separate video because I think this is one of the most difficult topics in this section, and I want it to have its own video.